Okay, new unit time. So what we're going to cover in this unit is exponential functions. Similar to what we did in year 10, we'll step it up a little bit more and then introduce the inverse of the exponential function, which is a logarithm. So here are the index laws from last year. Hopefully you don't need to remember them, but you just need to use common sense to try and apply them. Okay, so let's get stuck into some problems. So the first thing we'll do is simplify this particular expression. So what I'm going to do is multiply the whole numbers together. So 3 times 2 is 6, 6 times 2 is 12. Then deal with the x's. That's x to the 1 times x to the 1 times x to the 2. That's x to the 4. Then we go y to the negative 3. So common bases means you add the powers. So it's going to be negative 3 plus 5 is 2. 2 take away 3 is negative 1. That's y to the negative 1. Now it's common practice, girls, to ensure that you express your powers as positive. So we're going to grab that y to the negative 1 and write it as y to the 1 or just y. Okay, this next one means anything raised to the power of 0 is 1, but that just means that the contents of this brackets is 1. This is 8 lots of 1s. This is 8 times 3x squared y, which is 24x squared y. All right, looking a little bit nasty here, this one, so let's just have a look at it. We've got all of this bracket here being raised to the 2, so that's going to be 25 x to the negative 2, y to the 4 over. Now this 3 doesn't get raised to the 3, so we leave it sitting out the front. We've got x to the negative 9 and y to the 3. Didn't really need brackets there. Okay, so let's simplify it down. So what we can do is we've got common bases being divided here. So the rule is we subtract the powers. So that's going to be negative 2 subtract negative 9. So that's going to lead us to 25 x to the 7. And this one here is going to be y to the 4 over y to the 3. That's going to leave me with just y. And it's still over 3. Okay, over here we've got one of those power to power rules here, and the contents of this is squared. So this negative here will just disappear because it's going to be negative 1 squared, and that's going to be 1. So I've got 9 a to the 4 b to the 2 over a squared. Over here, I'm just going to write that as divide. In fact, let's skip a step here. Because it's dividing by this fraction here, we're going to straight up multiply by the reciprocal of that, which is 2b over 3a squared. Now let's have some fun cancelling. So I'm going to lop out those and leave 2 of those. Get rid of that, leaving 3 of that. Now let's go ahead and multiply. Oh no, that can go with that. And now I think I'm ready to multiply. So that's going to be 6b to the 3 over 1, or 6b to the 3. Okay. Getting a little harder this time, but not really. Now notice that this problem here has all of these numbers can be written as base 2 numbers. Okay, so 2 to the 2n, let's just leave it as that. What I'm going to do is rewrite 8 as 2 to the 4 and take 1. That's a big mistake. It's 2 to the 3. Now 16 is 2 to the 4, 2n plus 3. All right, so now what we've got is common bases. Okay, so what we're going to do is just use that rule, the power to power rule. That means that these powers get multiplied. So I'm going to rewrite this line as 2 to the 2n times 2 to the 3n take 1. Now don't forget those brackets there, they're really important. 2 to the 4, 2n plus 3. Because remember, power to power rule means one power raised to another power, you multiply the powers. So it's 3 lots of all of n take 1. So the common mistake I see there is students not putting brackets in. 2 to the 2n times 2 to the, what's that going to be? 3n take 3 times 2 to the 8n plus 12. And that we've got common bases, so what we're going to do is add the powers. So we've got 2n plus 3n, which is 5n, 5n and 8n is 13n, 2 to the 13n, and that's going to be plus 9. Okay, this last one here. Okay, so you might think, oh yeah, that means that square that and get x squared plus x to the negative 2, but you'd be wrong. Okay, so what we're going to do is expand the perfect square. There's two ways of doing it, is by rule or by simply writing x plus x to the negative 1, x plus x to the negative 1, and use the distributive law to simplify it. So that's going to be x squared. That's going to be x, that's x to the 1. That's going to be, what's that going to be? Common bases being multiplied, add the powers, that's x to the 0, which is plus 1. Then we're going to do, so what have I multiplied so far? I've multiplied that by that. And I've multiplied that by that. Okay, so now I've got to do that by that, which is going to be 1 again, and that is going to be x to the negative 2. Okay, so we've got x squared plus 2 plus x to the negative 2, and I would just rewrite that with a positive index, x squared plus 2 plus 1 on x squared. All right, I would actually not go through all of those steps. I would write this using the rule. So that's going to be x squared, that by that, which is x to the 0, which is 1, multiplied by 2 is 2, and then that squared is indeed x to the negative 2 equals x squared plus 2 plus 1 on x squared. So I find the rule much easier to use. You see here that I struggled with the distributive law. I got tied up in what needed to be multiplied by what, but yeah, it's much faster with the rule. Okay, so there's your practice for 13A, and let's get on to 13B. So hopefully we know so far that the root of A can also be written as 8 to the half. So 8 to the half is basically saying, can you square root this base, please? Okay, so y root 3 equals, root 9 equals 3. Square rooting is the answer to the question, what multiplied by itself equals the number under the square root sign? The number under the square root sign is 9, and what we can do is rewrite that number so it can also be written as 3, or we can write it as 9 to the half times 9 to the half. Okay, now why are we allowed to do that? Well, what is 9 to the half times 9 to the half? That equals 9 to the 1, i.e. the number underneath the square root sign. Okay, so I have to do an edit here. Okay, now on to rational indices. So hopefully you know or have seen this year that the root of A is equal to 8 to the half, and again it's important to know why. So we know that the square root of 9 is equal to 3, okay, but we can also write this number here, or the number 9, as 9 to the half times 9 to the half, okay. Now, why am I allowed to do that? So common bases, add the powers, that's 9 to the 1 equals 9. Now, what was the point of that? Well, the definition of square root is what multiplied by itself equals the number under the square root sign. So 3 multiplied by itself equals 9, but also 9 to the half multiplied by itself equals that. So what we can conclude then, girls, what multiplied by itself, in this case, we can say the square root of 9 is 9 to the half, because 9 to the half multiplied by itself equals the number underneath the square root sign, or 3 does as well. And it's the exact same idea behind the third root, or the cube root. Okay. All right, what we're going to do is use our knowledge of this to evaluate these without the help of the calculator. All right, so what we're going to do is rewrite 64 to the 1/3 to the 2. So what I'm going to do, first of all, is grab the third root of 64, which is going to be 4, and raise that to the 2. So that is equal to 16. Okay. Now note that this could be done the other way around, so I could do it as 64 squared and then grab the third root of the result. But firstly, I don't know what 64 squared is, and secondly, I wouldn't have a clue once I do that what the third root of it is. It will be 16, but I just can't manipulate those numbers. So there's a very particular strategy to doing these problems, and I would not employ that one. All right, 27 to the power of 2, and we want to third root the results. So I'm going to rewrite this as 27 to the 2 to the power of 1/3. Now again, I've got no inclination to do 27 to the power of 2, but this is one power raised to another, which means we multiply the powers. And because it's multiply, what I'm actually safe in doing is rewriting that as follows. All right, and the third root of 27 is 3, which when I square that is equal to 9. Nice and easy. All right, this is virtually the same problem. Okay, so this is going to be 125 squared to the third, which would be the same as doing the third root of 125. Now that's going to be 5 squared, which is 25. All right, this one. A couple of ways of doing this one. So what I'm going to do first of all is rewrite this as 25 to the negative 3 on 2 over 16 to the negative 3 on 2. Now I'm going to use the negative index law to bring that to the top, that to the bottom. So that's 16 to the 3 on 2 over 25 to the 3 on 2. Okay, now what I'm going to do is go 16 to the half to the 3 over 25 to the half to the 3. Okay, so the square root of 16 is 4. 4 to the 3 is 64. Square root of 25 is 5. 5 to the 3 is 125. There it is, 64 and 125. Okay, so what we've got here is common bases. So what we've got to do is add the powers. Okay, so people think that you need to treat this differently because of fractional powers, but it's exactly the same as if they were integer values. Okay, so I've got to do x to the 2/3 times x to the negative 1/3. So that's just going to be the addition of those two. So that's going to be x to the 1/3 times x to the 5 on 2. So what I've got to do is stick a third onto 5 on 2. Can't quite do that in my head, so I'm just going to go 5 on 2 plus 1/3 times 3 times 2 times 2 times 3. 15 on 6 plus 2 on 6 is 17 on 6. X to the 17 on 6. That's the best we can do with that one. Okay, this last one here. All right, so the first thing I'm going to do is let's cancel the x to the 3 with those. Get rid of that and write that as 5. Now let's rewrite what we've got. We've got x to the half times y to the 5 times y to the, that's the square root of y cubed, which is going to be y to the 3 on 2, over. All right, I've got x times x to the 3, which is x to the 4, multiplied by y. All right, that one's going to go, leaving 4 of them. And what I'm going to do is bring this to the numerator, the denominator rather. So I'm going to rewrite this as y to the 4 times y to the 3 on 2 over x to the negative a half times x to the 4. All right, so we've got common bases. So what we need to do is add the powers. So 4 is 8 on 2 plus 3 on 2. That's y is 11 on 2. Over common bases, add the powers. That is going to be 8 on 2, x to the 7 on 2. Okay, now this one here, again, common problem. Okay, so now what we've got is this being multiplied by this, and the base here, okay, so that is being raised to the power of 1. So this is common bases being multiplied, although what we've got is 2 terms, okay, but it's still the base. The base is the base. All right, so it's x plus 1 all to the 1 times, so I'm just going to rewrite this as x plus 1 the 1 times x plus 1 to the negative 3 on 2. So common bases, what we do is we write the base down and we add the powers. So that is going to be negative a half, and that's going to be the same as 1 over x plus 1 to the half, which we could write also as the square root of x plus 1. Okay, this one here will do the same thing. So we've got common bases being multiplied together. So let's just write the square root in index form. And common bases, let's add the powers. That's going to be x take 1 to the, what's that, 5 on 2, 2.5. Okay, so there's your practice at the negative index rules and rational powers.